I'll just give you a short demo of this. So F-sharp data is a library, open source library I've been working on. It's on GitHub under the F-sharp organization. So you can contribute if there's something missing or if you find some bug. Oh, what's happening? I'm in the wrong solution. The library basically lets you access various data sources. The interesting ones that you can use are various structured file formats like CSV, XML, JSON. And then it also has a type provider for getting data from the World Bank.
I'll show that later.
Yeah, and from Freebase as well, which is this Google. So Google recently bought it, so I can't talk about it here. Okay, so I'll just show you a simple demo of this. So we can load data from CSV files just by referencing the DLL, and this is the wrong file. This is the one. So reference the DLL, and if I want to get stock prices from Yahoo, for example, which Phil might need to do later on, then I'm going to call the CSV type provider, and this is generating a type for parsing CSV files that have the same structure as this sample. So the URL or the path here is just saying, if I go over there, this is my sample CSV file, and it has these columns, and these are some sample data. So what's happening here is that it figures out what's the type of the individual items or rows in that file by looking at the sample, and when I get the first row, I think I'm not online. So I'll need to load the data from the local file instead of getting live data from Yahoo. Now I can parse the first line, and you can see what I'm getting there. If I look at the different properties, like adjusted close, date will be a date time because all the values in that column match the date time format, and so on. So CSV file is pretty boring, but if I work with XML, then it gets a bit more interesting. So this is just doing pretty much following the same pattern. Here, I'm passing it XML sample in line. That's useful if you have some small data. But let's scroll a little bit down. What kind of cool examples do we have? Okay, here's one where I give it an RSS feed. So this is that's not going to work because I'm not online.
There's a little piece of paper with the internet on it.
Ooh.
No,
It's on the whiteboard.
it's on the whiteboard.
It's on the whiteboard.
Yeah.
On that part of the whiteboard.
Yeah.
Ooh.
It's easy.
US MSGS. I can do that.
I'll pull it out from
I don't
Password
understand English. I'm just
J7.
European.
Ah,
J7 sec AE6. J7 sec. Yeah. J7 sec EA.
AE.
AE.
6.
6. I have 6. No, I have.
Capital J is uppercase.
J is capital.
Yeah.
Ooh. J7 sec J7 sec A. So when I run this line, it well, when you open the file, it actually connects to get that RSS feed as a sample, and based on that, it will build a type that represents a RSS data source. So when I actually tell it to download the data, I get some value called blog of type something.rss, and it figured out that RSS feed has channel element inside. Channel element has copyright, description, link title. It has multiple items elements. So it generated getItems method, and this is returning an array. So we can really easily print the title, iterate over the items, and you just don't have to even look at the XML file to figure out what's the kind of structure there. You can just put it into the type provider and just use dot-driven programming to write whatever you need. So you don't need to install web browser or anything like that. Just need Visual Studio and F#. One other cool thing that I want to mention is that if you look at this sample file, this is actually a documentation for the library. So when I write an F# comment using the opening parentheses and 2 stars, I'm actually beginning a documentation block, and inside this block, I can write some text, but I can also use various markdown formatting commands, like start a heading, or there would be a link somewhere down here as well. Like here, this is creating a link, and this block is a code sample, which is not in F#, and this is all automatically. Oh, what's new on Stack Overflow? These files are automatically turned into a nice HTML documentation. So if I go to the project website and select something like the XML type provider, then this page is actually generated using another tool that takes that F# script file, picks up all these markdown documentation blocks, generates an HTML from that, and the rest, which is the F# code, that will be formatted as code, and it also adds tooltips, so I can look at it and see what the types are. So name would be a string, and so on. So if you're interested in getting some data using type providers, then check out F# data. If you want to find out how does this formatting? Ooh, who's that guy? How do I go from that way? Oh, that's better. If you want to do some open source project in F#, have a nice documentation for it, or even document your internal APIs or libraries. The library that was used to build the website is called F# formatting, and there's a documentation for that as well. So it gives you side by side a sample. Let's go here. Side by side a sample of what you can write in your F# script file and what will the output look like. Okay, I think we can go to the main game now.
Let's go to the slides.
Yeah.
Great. Hi everybody. My name's Phil. I work for a company called Trayport, where I'm a developer and architect. Worked there for just over 4 years. Trayport are a world leader in energy trading software, which is used by traders, brokers, and exchanges. I've been using F# for nearly 7 years now. I started at Microsoft Research in a machine learning lab using F#. Hugely valuable, hugely useful. I've been using F# where I work at Trayport. We also use C++ and C#, so a combination of languages. I'm from the UK, and I help organise a youth group called the Functional Londoners, which has been going for just over 3 years. We've got 500 members, and we actually meet every 2 weeks. Every month we have a talk like this, and in the other part we have practical hands-on coding dojos where everybody gets down and does some code. Also every 4 to 6 weeks we have a code sprint on a Saturday, which is where we all get together, or a group of us get together, and we try and hack on something for a whole day. So the Vim plugin, so you can have F# in Vim, that was written in a day at one of these code sprints. We get people from all sorts of backgrounds and abilities. So people will come in on, say, a code sprint with no experience, or one of the coding dojos. We also have really experienced people. So it's a really exciting place to be. Our events are hosted by Skills Matter. Great team there. And they host an event almost every night in development. So London's a really exciting place to be. There's 500 members, and just to put that in perspective, that's quite a lot of people. That's about the same number as the .NET user group, and twice as big as the Haskell user group. So F# is not small, in London at least. We'll look at New York in a second, but this is big business. This is a big side of things. And I guess, what's the story behind that? It's finance. London is one of the financial capitals, and there's a lot of finance, a lot of insurance, a lot of startups. And I would say we've got 1/3 trading finance, 1/3 insurance, and 1/3 startup from the people coming in. So lots of very interesting people solving very interesting problems. And here's you guys. So you've also got 500 members. Really impressive. You've been going 6 months less than us, so I'm a little bit jealous of that. Loads of meetings, and it looks like you're getting great turnout, so really excited about that. I love stats, so I'm going to punt you guys for stats now. How many people here work in trading or finance? That's over half. How many people work at a startup? Got a couple. And in insurance? Line of business. Okay, so it's pretty much all finance here. So I guess probably the title of this talk's probably led more people to come from the finance sector. So that's not everything. And then from a development point of view, how many people have programmed F# before? That's pretty much everybody. C#? That's most of the audience. C++? Haskell? We've got a few hands on Haskell. Python? Let's try and go for something obscure. Algol 62. You've got one, brilliant. Okay, great.
The London team is in Meetup too?
It is on Meetup, so it's meetup.com F# London. But that's just kind of like, that's London and New York. And London and New York have the largest user groups, and they also have very large financial centers, so there's something in that. Now this is the Meetup group map that Thomas made, which is on fsharp.org, and then you go to groups, and you can see these blue spots. These are actually F# user groups, which are just pure F# user groups meeting up every month. So we've got good scattering across Europe and Scandinavia. There's actually groups in China, Japan, There's a little outlier in Brisbane, and that's a functional group down there. Really great guys there. But there's F-sharp user groups across the west and east coast. So, you know, this is a growing thing. We see there was a small group had a meet-up in Dublin recently. So it's something that's expanding. So I'm going to do a kind of who, why, what. I'll answer some questions about F-sharp, and then we'll go into some code later. So at least from a London point of view, inside the trading group, we've got a lot of people from investment banks, some of the very large investment banks in London, hedge funds. So the investment banks, some of those were the first people to come into F-sharp back in 97, 98. This is a long history. So 2007, 2008. Yeah. Spotted that deliberate mistake. So we've got hedge funds, proprietary shops, utilities, insurance. Those are some of the spots. We've got people who are in consultancy businesses doing a lot of F-sharp consultancy work as well. So it's not just full-time employees. We've got contractors going out there doing good things. And so why? Why are people using F-sharp? So pretty much everyone in the audience here is or has come in contact with F-sharp, but these are the typical reasons that people in the F-sharp community have found for using F-sharp. One of the principal reasons is time to market. They need to get to market more rapidly. Efficiency. You need high performance code. These are things that are really important within finance. Also correctness. You can't have big mistakes. Dynamic languages don't really work so well for you here. And you don't want lots of bugs at runtime. Traders get really upset, particularly in London, when things go wrong. So you don't want to upset them. And complexity. And again, this is something we find a lot of in trading. Actually, just as an aside, where I work, about a third of the developers are ex-games. And there's a lot of us coming from 3D video games into trading apps, because there's a sort of similar level of complexity, correctness, efficiency, and time to market problems in a video game, or most video games, unless I used to work at Bullfrog, and they tended to be about 3 years late every time. But they could get away with it because everybody loved them. So just sort of digging in a bit deeper to that. This, again, you can go here, F-sharp or testimonials. This is a great place to show your boss or your decision makers why people have got into F-sharp. Because you can see real feedback from people on what's happened to them, rather than me just saying monads are great or some other meaningless stuff. So, large European investment bank, development speed up to 50% more productive using F-sharp. Now, just as an aside, we can't name these people, but one of the things that I found interesting is that a lot of people have gone straight from C++ to F-sharp and just skipped C-sharp altogether, because they didn't see enough of a time to market productivity boost in just going to C-sharp. Because, you know, it's an incremental change, but it's not an order of magnitude. Which leads us on to the next one. This is a company called GameSys. So this is outside of trading, but quite a few guys have actually come from trading. They're doing online gambling. They've seen order of magnitude increase in productivity. So in effect, taken an entire team of Java developers down to one guy, gone from releasing every 3 months to every 2 weeks. Right? They've taken a team from 6 people to 85 people in the last year. They've got approximately 700,000 users per day using their site. So amazing value from F-sharp. So that's just a time to market thing. You know, for me, you can turn around features in F-sharp so quickly. Things that I just wouldn't even contemplate doing in C# or C++, because it would just, I know it would take too long, I can just knock them out in a few weeks, and I'll show you some of those later. So then we've got efficiency. Processes that used to take hours just take minutes. This is a large insurance company. These guys were using C++ before. And if you look deeper into that testimony, you'll see their ability to just focus on the complexity, understand it, and focus down on those algorithms was what was giving them the performance, not just high performance tweaking. But just as we come on to, well, we've got C++ again down here. Performance is 10 times better than the C++ version. Right, this is Aviva. Aviva's the 6th largest insurance company in the world. Okay. Some of the early experiences I've had with F-sharp. I remember I'm a C++ coder, a games coder, so I do know a little bit about performance. We had a kind of game at work, which is to take interview questions from large investment banks and see how quickly we can answer them. And one of them was from one of the large investment banks in London, which was to calculate left truncated primes. It's a completely obscure, useless task, but kind of fun. So we did it in C++, C#, and I did one in F-sharp. And then we ran times just for fun. The F-sharp version was twice as fast as the other two. No optimizations were done. C++ guys were really upset because the assumption is always that you write something in C++, it will be faster. And then weeks were spent trying to optimize it, for no value whatsoever apart from to save C++'s face here, so that we could get comparable times with F-sharp. So the moral of the story is C++ isn't, you can make C++ go fast, trust me, you put it on Xbox and you tune it like hell, you'll get there, but unless you actually observe it, compare it against something you write in just high-level language, how do you know? Okay, performance. Next, bug 3. Now, a lot of people have reported this anecdotally, but when you write some F-sharp code and the compiler says yes, typically when you run it, you relax and it works. Right? This is not the experience I have with C++. When I write C++ and C#, I probably go and walk through it a few times in my head, look through code, have no real expectation of it working first time. So the compiler's got your back on F-sharp. This is a quote from Fixed Income Company. Below we've got, I'm still waiting for the first bug to come in. So this is from Simon Cousins at Eon, which is a really large utility in the UK. And he's been releasing for years now, 3 or 4 years, and he still hasn't had a bug come back. And this is just completely unheard of. And I believe they've replaced an existing legacy C# system, which was about 10 times as much code, riddled with bugs. Again, you can read all about that on the F# org site. Just kind of picking different examples, but complex algorithms can be expressed succinctly. So on the complexity side, and this is going to be my experience, is you have something that you can't see the wood for the trees in quite verbose imperative languages. You express them in F# and the natural what's happening just kind of shows itself, which I really like this comment from Byron Cook. Everything becomes simple and clear when expressed in F#. This is why I love using F#. You read it, you can understand it. So Byron works at the machine learning lab in the research lab at Microsoft, and he's actually has software that solves termination for C programs, which has been used, which is supposed to be impossible, right? Which has
I
been,
have approved.
which has been used in the Microsoft device drivers. So they can actually, and they found a bug, a termination issue in the sample device driver that they were giving to device drivers people. Anyway, so since the Terminator software, great name for a termination-proof system, came out, we've had much less problems with device drivers. And I think you probably, if you're using Windows, you'll have seen over the last 5 or 6 years that it doesn't blue screen as much. And a lot of that's down to this work that's just been happening in F#. So that's pretty cool. There's a huge number of testimonials. We started putting them up only a few weeks ago, and we've had huge response from people who have just had such a good experience with F# they wanted to share it. And if you have one yourself, just feel free to drop us a line and we'll add you to the site. So, kind of summing up what F# is, F# is a practical, functional first language that lets you write simple code to solve complex problems. So, just kind of dig into that. The practical side is it's .NET, right? And Mono, and other things which we'll come to, but you've already got all the libraries there. You can leverage your existing code bases. So you can leverage your .NET code base because you've got easy interrupt with C and C++. Basically, it's not Haskell. And it's a functional first language. So it's a functional language, but it's functional first. You can still go and do imperative code. You can mutate things. You can do object-oriented programming when you need to tune it for. You write simple code, solve complex problems. So if you don't have complex problems or problems to solve, you're doing CRUD, this is probably not that much use to you because you're not solving code problems, right? But if you are, it's a great language for it. There's another term I saw that F# is pretty much a premium code language, right? So you solve problems with F# with code, not with wizards and boilerplate and SQL Server. You're there, you're in the zone, you're in the code. So we've had quite a lot of talk there. I'm going to move on to showing you some real stuff. So show me the money. One of the applications I've been working on Trayport is a trading screen called Joule. It looks like this. It's used by a lot of energy traders for European energy. Also, we have offices in New York and Singapore, so there's a lot of trading going on in North America and Asia too. I'm going to show you a video of this running, but a lot of the high performance code here, the complex code here, has been written in F#. We also use C# for plumbing tasks, for some of the code generated part. There's C++ on the back end. So there's a mixture of things, but F#'s been used for solving complex parts. Our energy trading screen, so energy trading is quite different from, say, stocks or Forex in that you don't really trade millions of tanker loads of oil per second, right? You generally want a tanker or you don't want a tanker. You don't want a tiny slice of it. So we don't have the same sort of volumes, but we could still have, say, somewhere in the region of 10,000 orders per second, right? So we've still got respectable volumes, but it is a different thing. And these blue prices you see, which is one of our core offerings, is that we actually look out over the graph of the market and imply prices. And that lets people see prices where there aren't prices before. So we can imply prices, say there's January, February, March, we can imply first quarter price. Right? What we can also do is we've got a first quarter price and we've got January, March, we can imply February. And then we can apply that recursively out, say 3 or 10 times, and we can actually fill the market with prices. And that lets people get a guide price on what they might want to trade. Or they can actually trade the implied prices, so you could trade, you could just go for that trade, take that spread if you want. So I can't walk around with the source code to that trading system on my laptop, so I'm going to just load up a video. So when we get past this part, hopefully you'll see this is a front-end application using F-sharp, and a lot of time people talking about back-end applications. This is really heavy front-end app. People might have 6, 9 screens all running on, all showing parts of our trading app with different charts and views. So now we can see the implied prices zoomed in there. I think that probably surprises people is you may associate functional programming with quite boring graphics. You know, we're talking about one of the most modern UIs out there for trading. So if you'd like to see more, just go to the Trayport website, trayport.com, and look at Joule. So Joule's used, our trading screens used by up to 160 customers of Trayport, which includes all of the major investment banks, utilities, hedge funds, and prop shops in Europe. Okay, so just sort of filling in the story a little bit. When I started at Trayport, one of the first areas that we used F-sharp wasn't actually in the runtime system, it was in testing. We needed to work out, before we reinvigorated the implied price engine, exactly what it did in detail. And the way we did that was to write examples of the system. And from there, we started to automate those examples, those English language examples, as you can see here. So this technique, the specification technique is called specification by example. It's also known as behavior-driven development. And the key focus there is actually to get those examples. And then once you've got there, you can actually test your code fit. Now this is quite useful because we've got code in C++, and we want to move to a new language, let's say F-sharp, but maybe in the future we want to move to G-sharp. We've got that specification available to us, so we don't have to throw away all our tests and start again. Now when we were doing the implied price engine, we actually did throw away 4 prototypes before we settled on a particular version. And the reason for that is that there's many trade-offs between performance, between memory consumption, and so forth that you can make. And we just had to try different things out until we got there. Now, because we've written the tests in English, it meant that we could keep those same tests and rerun them. So I guess I should actually boot up some code now, right? So for the developers, which must be most of us out here, probably been waiting to see some code.
Which database platform you use for Joule?
Oh right, for Joule. So on the client side, there's no database. On the server side, we typically recommend SQL Server.
Microsoft or
Microsoft SQL Server.
can you use different one like MySQL, or you can use any?
Currently, the only one that we would support would be SQL Server. But for our trading system, the database is in effect just a store of trades. It's a store of events that have occurred. unlike a web app where we would do a lot of reading, it's just basically a repository store, so it's not a huge part of the Trayport offering. Most of the high-performance system has to work in memory, and we just use the database as a recovery
You can
fail
use like
state.
data analytics, like any big data.
So we offer an API, and what people generally do is they will link up to the Trayport API, and then put it into whatever risk management system or an analytics system. We'll look at analytics in a little bit. So the area I'm going to show you is behavior-driven development. There's a framework called TIC-Spec, which I wrote a couple of years ago. It's quite popular for F-sharp users in trading. And there's a whole bunch of example things you can have a look at. We were just looking at implied prices. And so you get you can get an optional plugin that gives you this nice syntax highlighting. You write in kind of a wiki text form, so you could just do it in a wiki beforehand. That's how we generally start, and then pull them into Visual Studio afterwards. This is a breakpoint. So I'm using something called test-driven.net just to run my tests, which you can use for any .NET language. And now I have a breakpoint in my text file. So I'll drop another one up here. And just for fun, so you can step over the things to find a particular scenario you're interested in. Okay, now there's a bit, yes?
Yeah, I have a couple of questions. Could you please describe what type of contracts you're trying to sell and some terminologies, saying implied price and
Oh, sure, no worries,
things
yeah.
like synthetic orders, because otherwise it's difficult to understand what you're doing.
Yeah, no worries. So, although for the purpose of showing the behavior-driven development, it's not actually that important. I'll do the implied price is a price, or a synthetic price. They're pretty much synonymous.
Yeah, but what kind of? It's like physical futures with physical delivery?
So with the Trayport system, you can use it for financial futures or spreads or any kind of financial instrument.
Well, but in particular, you just trade in commodities.
In commodities, people tend to trade futures, forwards, and spreads.
Okay. And what
Whereas
is
in,
implied,
say,
what in that context, what implied price would be?
well, the most common implied would be to imply in or out of a spread. So there's a number of different spreads. So I'll try and explain trade.
Want to evaluate actual price for that particular market or what?
Yeah, so I mean, the word implied is the most important thing in implied pricing. So where you'd have, say, an outright price, that's somebody that actually is willing to buy or sell at that price.
Okay.
Okay? An implied price is where we've said there's, say, a price somebody's offering to buy, and one person is offering to sell.
Yeah.
So we can imply a spread, a buy-sell spread.
It's
Right.
like
So
it's theoretical, or it's mark to market.
It's theoretical in that not one person is offering that price, but you can
It's like a
trade
fair market price, is it right?
No, it's an implied price. So you can trade that price, but instead of trading with one person, if you want to buy the spread, you'd actually buy the buy side and the sell side.
Okay.
Yeah. So for that to happen, what the Trayport system has to do This has to make sure that you have credit agreements with both the buyer and the seller, or you can sleeve the price. So I guess like the simplest spreads are the simplest version, but as I was trying to do earlier, a calendar spread is probably the easiest example. A calendar spread is to say.
Is it like a derivative product or what?
No, it's not a derivative product. Perhaps because I think there's quite a few people who are
Yeah, but if it's just a calendar spread, it's like it sounds like a derivative product on some kind of underlying product.
It just means that your products.
Yeah, so a calendar spread is something, for example, where you would buy January and sell February.
Different maturity days, right? The calendar spread. Right?
Yeah, a calendar spread would be where you buy 1 month, sell another, for example.
Yeah.
I think we might, because I'm talking about trading, but I didn't want to do sort of an intro to trading. If you want to chat afterwards, we can.
Yeah, but no, I just want to figure out what kind of analytical machinery are you using, and also what's the behind the scene of that.
Cool. So we're implying prices. We can imply prices pretty much through calendar spreads, standard spreads, pretty much any financial product, derivative, non-derivative. Financial, it could be physical. It really doesn't matter. They're apples and oranges really to the system. It's very powerful in that way. In this particular example, we've got V1 and V2, which could be forward spreads, anything. And then it's going to imply a spread from the buy and sell side. And then we want to basically say, given that we've got those, we should expect that bid price. So if our implied price engine is working, it will give us that price. Okay, back to the code side of things. Now for the magic, right? So how do we get English language text to automate our business system? There needs to be some code somewhere that ties it together. I can find it out by pressing don't do this in I can do that by pressing F11. I'm going to do it a different way. So we're in quite soon in here, but you write a function, and in F# you can have white space in your function names. So in effect, when it sees when a market has outright orders, it will pass the table in, and will convert that table of orders to a table. Right? It will store off the table as orders, and we can do the same. For the, so those are the orders coming in, and these are the orders going out. And I've left this bit blank, this is just a sample, so I haven't attached our trading engine. But this is where you would attach the trading engine and find out where the values go. So it's actually ridiculously easy to plumb your English language specs over to your code here. So a couple of lines of code to do that plumbing work. It's pretty. So, just coming out of the trading side of things, we managed to, by using specification by example, we were able to understand systems that we hadn't done, we hadn't had a full understanding of, have very terse, readable examples that we could use to generate new systems and then be able to extend those systems. So one of the earliest things we did was to write the tests in F#, target a C++ system via COM, and then extend that C++ system by the tests that we had in place. So we wrote new examples with new functionality. When we saw how quickly we could use F-sharp to get things going just for these tests, at that point we had pretty much a green light to go on other parts of the system. So I guess where I'm coming from, this is how Trayport got into F-sharp really early on. If you want a nice, easy place to get into F-sharp, testing your existing code and understanding it better is a good place. You don't necessarily want to be on your first day of using F-sharp checking something in that goes live, right? Without somebody maybe holding your hand or giving it a code review. Right. So you can do behavior-driven development. This technique, the most popular technique library for behavior-driven development is called Cucumber, which is a name not to do a search for on Google or Twitter, I found, when you're on stage. All sorts of interesting pictures come up. But the guys love the name. There's another name called Gherkin, which is the name of the language, the given when then part. And then there's frameworks called Relish, and they're completely unsearchable. But there's been over 3 million downloads of the Cucumber framework. The Cucumber framework's used for Ruby. I don't know what that really proves. It doesn't mean there's 3 million people using it, but it does mean that this is quite a popular technique. So if you haven't come across it before, you might be interested. We quickly thought it doesn't solve all problems. When you've got complexity, you need to specify by example. It's pretty useful. For pressing buttons and things, I wouldn't recommend it. Some people go and automate the website. If you can automate the website, use a website automation tool. Okay, so I'll pop into the code in a second. This probably isn't coming out too well here. But obviously you can do unit testing with F-sharp. When we have new people starting on our team that haven't got F-sharp, got C# background or C++, we actually let them write tests in F# initially, and it's a great way for them to get a handle on F# and see some of the value from it. Again, having the white space in the test methods lets you actually focus on what you're testing and not trying to work out how to do Pascal casing. And it means you're more likely to change the test name to what it really means when you finish it, rather than leaving it with some crufty Pascal name because you don't want to go through that pain anymore. The light syntax here, you might think that F-sharp's a dynamic programming language because you're not seeing types everywhere. It's a statically typed language with stronger typing than C# and probably C++. It's just using type inference. So basically, the compiler's working that stuff out for you, which is a good thing, right? And it makes refactoring a lot easier. All of the standard unit testing frameworks, and this is very, very mature in the .NET world, are available and work with F# as they do with C#, including mocking libraries. And then there's some cute stuff that, some cuter libraries that are F# specific. There's one here called FSU. I'm going to go into the code because you guys at the back can probably squinting. I'm expecting you can't see anything at this point. Because we're doing finance, I'll use a tax example. Everybody loves tax. And death. You can see the test name. We put in an attribute here, so you can put it actually in line or you can put it above, wherever you prefer. You don't need a class. You can use a class if you want to. That's just noise. Right? Just like let, test, and the English language you want to write. We're nearing up a product here. which is a class. You don't need to put new. When you put new, the only time you need to put new is when you're newing up an iDisposable object, right? So you will explicitly know your iDisposable objects by the fact you have to put new on. This is quite useful, I find. C#, there's no way of finding that out without looking at the docs. In F#, you can just hover over it. This isn't iDisposable, so it doesn't say it's iDisposable. Here we're making a mockery of tax. And so we can mock this tax type. Now in C# you typically use a heavyweight mocking frame, which is what I'm using here. But in F# it's something called an object expression, so we could probably rewrite this without using any framework at all, which is what most people do. Let me just have a look at the type and I can probably, yeah. So this was using a mocking library, but we can use a object expression, which is basically an anonymous class implementation over an interface, and there you go. So no mocking framework, we've mocked a type, one line of code, winning. So the reason you'd use a mocking library would be, let's say you've got some C# type with 20 members on it, and you only want to actually mock out one particular type. The reason, more often than not, is when we're testing C# code that we use mocking libraries, these kind of things. And that's because we're trying to get our C# coders to use F#, and they're testing their C#. Okay. But just to see if it's all possible, we can do verification, and you can see it's nice, should equal 30. So you can actually make your F# code, your test code, read like English. So I don't necessarily always recommend doing the text file. If you're, that we saw before, if you're working in a purely development environment with everybody who's doing the business side, knowing about coding, why not just have a DSL that reads like English anyway? Just if you're interested in the mocking library, there's a one for C# called mock. I went online and said a while ago, I've written my own mocking library for F#, what should I call it? And don't ever do that, because it's called FOC now, or as mock is called mock or mock-you, my mocking library is called FOC or FOC-you. I'm working on a version 2, which will be interesting. Okay. Anyway, testing works out well. Sharp. It's a good way to get started. Go back to the slides. Okay. One of the next areas that we touched on was domain modeling. So I like quoting other people. This is from ThoughtWorks Tech Radar. How many people here have heard of ThoughtWorks? That's not everyone. Okay. So ThoughtWorks is a large consultancy business, mostly on software. A lot of their stuff's around the JVM. One of their consultants is Martin Fowler, Rebecca Parsons. So some quite famous devs. They do a lot of talks. And they produce this technical radar every 6 months where they look at different programming languages and get excited about different ones. And they generally get quite excited about F#. So this is what they said last year. F# is excellent at concisely expressing business and domain logic. This is something that we use F# a lot for. And people trying to write stuff might want to express their domain in F# and do their plumbing in C#. Right, so that's kind of where they're sitting, and that's a lot of what I've been doing over the last few years. Kind of going back to the testing part, once we got our tests up and we kind of started to understand what we were trying to solve, we managed to take classes that were sparing tens of files and condense them onto a single page and have them on a page, and we could finally truly understand what the code and what the system did. That's hugely valuable, and there wasn't anything missing there. We just actually knew what it did, and at that point you can evolve it. There's also having that simplicity there means that you can feel happy about changing the way you've modeled it without having to rewrite 10 files or 20 files or touch it, hold it all in your head. Just do it. It's a 2-minute job. So that's kind of one of the useful things. I think one of the reasons I'm drawing this out is because people think of F# as, or these functional languages as not being good at objects, but actually they're awesome. So in trading, if I wanted to express an order, which we saw earlier, so it would be a bid, an offer to buy or sell. We'd have a limit price, a quantity, and for our cargo tanker example, is it all or none? So can I trade part of the oil tanker, or is it all of the oil tanker? And there you have it. Now, if I did this in C#, this would be about 50 lines of code with boilerplate. Here, it's just as is. It's just lovely. You just focus on the problem you're trying to solve. So that's a record type. On the C# side, you'll see a constructor for this with all of the nice things filled in, with all the names there, and you'll see these as properties. And that will generate an immutable record type. Okay? So you can use those safely. They work in parallel code. It's just awesome. There's a keyword called with, so you can generate new versions of it. So you don't need to use mutation at all. So we use this inside of our trading system. One of the next really useful types, which again you won't probably have seen in imperative languages, well actually you might have done, it's a union type. So if anybody use C, right, so in C you had a union, right? Now these were quite crazy things, so you could basically have a space, and the largest one is the space size, and then you might put a tag in to say which version it is. This is like a union, except in effect you have a pointer instead of having the block of memory in line. So you could also think of this as an enum on steroids, right? So where you would typically have an enum which might be immediate, good for day and good till day. Oh, damn, I need to actually put the date in, right? You can have enums which can have values inside of them. This is hugely valuable. So in effect, I'm just going it from a complete and yet another angle. This is an abstract base class, and these are sealed implementation concrete classes of those. So I've created an abstract base class and 3 classes in 3 lines of code. And this is pretty much one of the strongest conciseness parts to the F# language. So literally we can express our entire domain on a single page of code. A very complex trading domain. If you get into F#, unions rule. Okay, units of measure. So just like from a type safety point of view, you can add units to your types. This is a town in the US, I believe. I think they're joking. I guess there's some irony there. But yeah, it's an interesting total. This is what happens when you don't have units of measure. We'll come back to this later. But it's a first-class feature in F#. I'll quickly show you some measure code. So to define a measure type, you just put an annotation on it that's a measure. So that's Xamarin in the studio. We'll come back to that later. I'm going to, the tooltips aren't completely there yet. We'll start off an F# script one. So you can see when you hover over, we've got a price and a size. Now I've actually made a deliberate mistake. Feel free to call out what it is. But if I get the total, a bit like what we just saw before, I take my price as my quantity. I get price of size. What I actually want this to be is the price would actually more likely be a unit price, right? And
what
so,
will happen if you add to this?
Yeah, I'll show you. Yeah, cool, that's a good one. But you can see now I've made it a unit price. When I multiply by quantity, I actually get a price, right? Which is the actual way you want your units. So units can really help you get your math in order. When I'm doing physics for my game stuff, I don't have to think anymore. Just put in the initial types and it's got me covered, which is great. I do have to think, but not so much about the correctness. So if we do a so all's good in the world, it's still a unit price. But if I were to have actually made that a size, size does not, so it's got you basically at design time, it will tell you about the error. The really awesome thing about units measure feature in F# is it actually infers when you do multiplications and divisions, squares, square roots. So you don't have to work that stuff out. You can do this in language like C# by having like a class hierarchy, but as soon as you do like a square, you've got to create a new type to deal with, right? And so it doesn't really scale beyond the most trivial toy examples.
How's the performance since it's a race?
Yeah, no, it's just going to go to, and the really awesome thing for us, because we care about performance, we're in trading, is that all of the type units to measure is just at compile time it's there. When it's compiled, all of that information is taken away, and they're just decimals or doubles. So there's absolutely zero runtime cost for you having all of this correctness. It's fantastic. You have your cake and you eat it. So, sorry, I'm using the slides to keep me honest. So, Excel, trading, almost everybody uses it, right? Who uses Excel? Oh, it's almost all hands here. So, There's actually a really great story for F# with Excel. People in trading often get to the point with 32-bit Excel where they've gone to the 2 gig limit and they're like, the 64-bit Excel's helping you out there, but it's a bit of a smell when your spreadsheet gets to the 2 gig size. So some investment banks have actually been taking, and insurance companies have been taking their Excel sheets and trying to get them into code, and they've been using F# because it's good for math, it's good for expressing these things. The Credit Suisse guys have got a talk on their Eden project where they're doing exactly that, taking Excel formula and rewriting it in F# to give them performance increase, to give them correctness, which they're not getting in Excel. There's a talk on video from the F# user group in London from last week that Matt Maloney did, but there's something like an average of 8 or 9 errors in every Excel sheet. So you know, it's good, it's productive. You don't have to get sign off from IT to use Excel, which is probably why people use it. But it's pretty dangerous. Some of the economic crisis has been blamed on Excel bugs or the austerity measures. So Thomas showed earlier a type provider to CSV and XML. We're going to have a type provider to Excel. Which is Excel itself is locked up. Okay, so we've got this sheet, and you can see there's a whole bunch of different column headings on it. And in effect, you've got IntelliSense to Excel if that comes in. Well, I think the fact that Excel just died might not be helping me out hugely there. I'm going to drop in something else. That'll teach me to actually load Excel up. So what we can do now with the Tsunami console is actually have an F# editor inside Excel, like you would so you can basically have F# embedded in Excel. You can interact with typed access to the Excel sheet. You can also write functions in F# which are immediately accessible in the sheet. So you've got basically VBA that doesn't suck. You've got a language that's terse and good for math, yeah. Debugging's not there yet, but it's a feature coming out. This is in beta. There's a public beta starting, I think, tomorrow. It's been a private beta up to this point. But it's pretty awesome because you can get all of those type providers you've seen and get really first-class access to data and use it inside. Now, although there's no debug inside the embedded app, you can still cut and paste your code that you're doing inside there, drop it into Visual Studio or Xamarin Studio, and have debug there if you do need to do debugging.
That's the most useful part of VBA. It's very easy to debug, modify, tweak, run again. It's just convenient.
Absolutely, yeah. To be honest though, one of the most useful features of F# is you never need to use the debugger. So, you know, it's like, yeah, I kind of like the F# approach. You can get there, but yeah, I think in a way the essence of VBA itself is why you need to do so much debugging. You've basically got typed access onto the sheet, whereas with VBA you don't. So you're basically picking up runtime errors, which you wouldn't get. Yeah, sure.
Also, I guess in F# people often use the F# interactive window to try things out and get to the right solution, which you can do in the Tsunami IDE on the right. You can select things that you code in F# and run them, and then when you see that it's working, you can actually call that from Excel once you know that it's probably going to work.
I'm not saying VBA is
Well, I'm going to give up on that demo because that's just not playing with me. It worked earlier before I tried to launch Excel, but there's something in that macro. Maybe it's not an interesting thing to do on stage. So anyway, yeah, the story on Excel is pretty cool there. There's a this is what it should have done. And yeah, actually I've had some really interesting bugs from working with Excel. We have like a Excel interop with our trading system, so you can push the prices onto your Excel sheet or trade them back on again, and kept getting a crash when you were copying them over. Actually, it's a bug in WPF, and if the clipboard is locked, right, from something else locking the clipboard, it actually freezes out your whole app and throws an application error after a while. So I have a function called try copy to clipboard, which has got a try catch on it. And yeah, I wasn't expecting that. It's not documented. So yeah, Excel can cause all sorts of interesting problems. Potentially, that's perhaps one of the weird things that was happening there. So I've done a lot of work with Excel, and sometimes I think it would be easier just to write it myself. So one week I did that, and I'll just show you that now. So I have an open source project called Cells, and it's an open source spreadsheet, and it basically does what Excel does. You've got all the kind of Excel functions and functionality, all the way down to the bugs. That was one of the most challenging things, was like finding the bugs. The first one was, and the one that freaked me out initially was, okay, one of the problems you have in spreadsheets is you could have a cycle, right? So you could reference yourself, or you could end up referencing yourself by referencing back on yourself. So, you know, I put a nice cycle detection code in, and then I discovered that Excel doesn't bother. So to get Excel compatibility, I still have the cycle detection in, and I put a warning up, but I just ignore it. It's a warning rather than an error. Excel, there's a setting for it, but after 1,000 times cycling, it gives up, thankfully. And that's a feature. Yeah, it's an amazing piece of software. So yeah, so you can see this is like a functioning spreadsheet. You can load and save Excel files in and out, and it also will pick up the colouring for you that you did on Excel, which is nice. So pretty much the whole deal. And then I was like bored. Happened. I thought, wouldn't it be cool to have like units of measure in a spreadsheet? Oh, we have. So yeah, this one has units of measure support. So we could. And it will handle arbitrarily complex units of measure. Yeah. So, oh, that's the number of lines of code there, all that stuff. Shall we have a look at the code quickly?
Yes.
Yeah, why not? So we have a look at some of the functions. This is where I implement functions itself. There's one line per Excel function. I don't have the Excel source code like that, or the support units of measure. There's a bit of cruft because I am supporting units of measure and I slapped that in. But in effect, for a sum, so you saw a sum earlier, summing over the set values. We take the values, so we've got a function name we match on, sum. Take the values, we come up into decimals, and then we call sum. Oh, that was hard. This is using the pipe, so I could have done list.sum. So if I'm doing in C# I do sum, brackets, decimals, brackets, values. This reads better.
Is that pivot tables?
Sorry?
Pivot tables?
Pivot table.
Oh, I don't support pivot tables, but I could do.
Nice.
Yeah, I'll see if I've got any time on the plane home. I can't imagine it's going to be that hard. So, yeah, count, average, if I really quite liked. So this is really starting to show you the power of pattern matching. So we're looking for a name of if, and then a parameter which is a boolean, right? And two values that could be of any type after that, which is the true or false value, right? And if the condition evaluates to true, then show true, else false. How ridiculously easy was that? That's it. You know, there is no hidden code. That's the implementation of it. Am I still running? I can actually just show you that running now. Let's just fire that up again. Right. So, yeah, that was just hitting that code there. I guess what I was trying to show here is this is a really powerful language, and it's not just about solving toy problems. You can like write a spreadsheet in a week, and you can put units of measure. You can do things that the Excel team can't do on your own in hours, days. So, question?
Do you have a favorite textbook? F-sharp, F-sharp.
It's a great question. Thomas's is great, but they're all great. So you've got me on the spot here. Rick's is great. You know, I'm on video, but I've read them all brilliant. And Thomas and I are working on with a number of authors a new book called F-sharp Deep Dives, and the idea there is to sort of go beyond like introducing the F-sharp language itself, and talk about problems and projects we've worked on, and explain how we solved them, what went right, what went wrong, so you can kind of go to the next level. And you can get an early access on that now from Manny. Good question. Quick book fight. So, yeah, that spreadsheet. So we've got spreadsheets covered from site providers. You could write RTD, but you can actually embed in a spreadsheet, or you can write your own spreadsheet. It's pretty crazy options. So the next set of slides. Computation. So a lot of people use F-sharp computation. You can use the standard tools. You can just use F-sharp out of the box, and you can do a lot of computation work. I was working in a machine learning lab at Microsoft. We did the Halo 3 work, the true skill work for matchmaking, just with vanilla F-sharp with units and measure. So that for that work, all of the game matches for Xbox Live go through this F-sharp created true skill algorithm. Later on, we used a similar kind of algorithm for ad center. So basically, all of the impressions on Microsoft sites go through the AdSense system, which will give us a list of adverts to show based on what's likely to make the most money. And that's running for an F-sharp system that was made in 2006, 2007. That's pretty cool. Again, vanilla F-sharp. So yeah, that made, I think that was a $80 million uplift in the first year. We want to talk about business value from F-sharp. There was it's kind of a little bit of a digression, but there was a bunch of teams across Microsoft research in different areas. I worked with a team in Cambridge, the winning team. We spent the 3 months of the competition, spent the first 10 weeks coming up with features. We're prototyping in F-sharp using SQL. Last 2 weeks writing the algorithm code out because we were ice cool. Ours was the only one that actually worked. That actually would run in the live environment. We needed to run over 5 terabytes of data and write out a mathematical model. The C++ and C# ones crashed and burned before they ever got to the end. Yeah, good story really. But you can just get a long way. F-sharp is quite familiar for people who've used MATLAB or Mathematica. So it was a great crossover. I'm not like a maths guy from background. I do 3D games math, but it was great being able to work with non-programmers, and we could work in the happy land, which was F-sharp. So I mean, as a developer, and as mathematics, we could all understand each other, which we wouldn't have done in C++ or C#. We also managed to create models that worked and that gave genuine value. There are a bunch of really rich libraries for .NET, like math.NET, and then there's some F-sharp specific ones. I'll have a quick show of that for matrix stuff. And then if you want to go to the next level, you want to distribute, we can also hit the GPU or we can go out to the cloud, we can go out over Amazon or Azure. Going right back to the beginning of the talk, the guys doing the social gaming, all of their stuff's running on Amazon. One of the things that a lot of people do is Monte Carlo. I'm not gonna write black shells on stage. But I mean, Monte Carlo estimation is just basically randomly trying and seeing the results. So we can estimate pi by chucking numbers into a square and seeing which ones are inside the square and which ones aren't. So it's a very similar technique to buying stocks. Oops. So let's have a quick look at that. So just using vanilla F-sharp here, we can create a infinite distribution by asking initialize infinite distribution, and then going minus 0.5, so that gives a nice little square. A little function says is inside, right? Done. It is, you know, the noise has just gone out of it though, because the types are being inferred for us here, right? And for the computation itself, we can compute over the distribution, take however many random samples we want to, where they're inside, we'll count the length, and then we've estimated pi. So I'll just do that. So we don't even need, this is a script, we can run it by pressing F5, or we can just press Alt Enter, and that will drop that in there. And then I can say compute, and there's an estimation of pi, 3.126. This is kind of fun. So if you're in coming from C++ background, you've got the same sort of capabilities there. You can inline functions. So you've got way more performance tuning capabilities in F# than you do in, say, C#. And with its kind of with generic kind of systems like this, it really shows itself. So if we take that code, I wrote a little plotting thing, about 50 lines of code. So we'll just plot instead of counting. There you go, nice picture. And you know, it's kind of happy times. There's just no faffing about. You just.
Is that any better than just using unit points? So because when you get to generate the random points.
Oh yeah, it's just the example of it. There's no. It looks nice.
Looks nice. Why do you need mathematics?
So, you know, I think hopefully everybody can follow this. You know, I've started in the past tried to show quite like realistic bits of code, and you know, people get lost and stuff, and I get lost. And, so that was just sort of using. Sorry, question.
Why did you open the lyrics twice?
Oh yeah, good question. I'm going to show you in a second. not for any useful reason, but it's because I was setting this up. So here we're using a library for matrix multiplication. So we're going to estimate pi using this particular library. But I'll come back to that. The reason I had that there. Have I got the loading problem here? With the F-core matrix library, there's two different versions. An open source version called FMAP, as a proprietary supported version called F-Core, and with F-Core you can run on the CPU the matrix code, and if you open .gpu on the namespace, it will take exactly the same code that you've run on .NET and run it on the GPU and give you between a 5 and 20 times performance increase. Nothing else to do. That's just insanely useful. So that's why I had the second one, was where I imported the GPU library. So there's also a team called LA-CUDA who has specialized in doing option pricing on GPU. We've done it for a number of large companies in the Switzerland region, and they have a GPU product. If you want to go really fast on the workstation level.
LA-CUDA?
Yeah, LA-CUDA. So I'll just go back. What I wanted to show you is this is the same code that I just showed you in Visual Studio. This is Xamarin Studio, which runs on Mono and lets you run your applications inside Windows or on iOS or Android, right? Or Linux and Mac too. So you can take all of the stuff that I've just shown you running in Windows and run F-sharp code on all of those platforms, which is pretty damn exciting. And you've got IntelliSense and all the things you have inside Visual Studio, inside Xamarin Studio. And so I can just take that same sample and I can say send selection to F-sharp interactive, and that will do the pi calculation. And we've gone for a few more iterations down there. So that's nice. That was a little bit of a tangent, but it's good. So back to the script. So I guess there's good options for math. There's good for vanilla and for matrix libraries. There's quite a lot of people doing that. So now we're going to look, how many people here have used R? Cool. R is not a programming language. R. And the R-type provider would be much cooler if it was this 80s video game. But the R-type provider is actually something that lets you access an entirely different language, R, a statistical modeling language, inside visual data and push data into the R language or pull data from it. So basically you can leverage the good bits of the R statistical library. I'll just show you that now. So again, using a bit of scripting, we'll just get some stock prices. We'll do some calculations in R. And that's actually popped from Visual Studio, drawn a graph via R. So F-sharp doesn't constrain you to the .NET infrastructure. You can go way beyond. And so if we just run next line, and there's a nice print from R. So That's pretty cool, right? So the type providers Thomas was showing before, same technology, and so here I've got typed access over the ER libraries. Winning. Okay, so Thomas was talking about the World Bank before. So let's say this is Thomas's sample, and what I'm going to do now is connect to the World Bank. So we say connect to the World Bank indicators, and that's actually going over where to go and get the data from World Bank. There and then. That's kind of handy. So you can access, that could just as easily be SQL Server or Excel, right? You've got typed access to just about any data source. Have you really ever used JavaScript? Not so many. So this is where things get really weird. So what we're going to do now, there's a library called jQuery that all the cool kids use for doing web stuff, because JavaScript's cool. And we've got a type provider that accesses type definition files for JavaScript. And we've now got, we're now accessing JavaScript library called jQuery inside Visual Studio from F#. And that lets us do some fun things. And we want to do some charting. We just did some charting in R, but what if we wanted to use some JavaScript charting library? So we could show our boss a nice dashboard and put it on the intranet, or even put it on the outside web-facing bit. Well, now I've got HighChart, so I've got IntelliSense over this JavaScript charting library. That's winning. So we've got like about 70 lines of code. We've got a bunch of different countries. We've got some stuff making some checkboxes with jQuery for the countries. This is where I'm going to go in a little bit. We've got this asynchronous block. So basically, if we want to do stuff asynchronously in F#, one of our options is to just put the word async over the front of it and pretty much let the compiler work it out for us. Oops. Just drop it down. Well, so we want to render asynchronously, and we're done. And if you look down there, that's line 80, and it's a single file out. Okay, so those are the countries that we've pulled out of the World Bank. And then we can like click on a few of those. And there's a chart. So, yeah, like hopefully, I mean, this is a bit of a drop of bomb thing, right? You know, we can connect to anything. We can connect to different languages, to different data sets. The F#3 is really the bomb. It's amazing what you can do. We're only just really starting to explore it. It's been out, it's mature, it's been out there a year. You know, it's part of the Visual Studio. This isn't like beta software. And the community, Thomas made a lot of this sample, been taking this to new and exploring new places. The R-type provider was written by Howard Mansell, who I believe comes to this group quite a lot. The World Bank samples from Thomas. The type provider to the JavaScript stuff is by Zach Bray. So it's all community, people leveraging on the language. So there's a whole bunch of really exciting things happening.
So, on this, after you manipulate the JavaScript, can you just, how are you getting the HTML output?
Oh yeah, so this is, yeah, I skipped over that form. So, where before we've been targeting .NET and Mono, here our F# is converted into JavaScript. And so you can actually just pull this page off and the JavaScript and drop it somewhere. F-sharp's being erased, right? That's kind of cool. So that's with the FunScript library, which is open source. FunScript, for me, is particularly useful for these kind of like dashboard apps, these one-page apps, which I think is where the web community is going. Why would you build a super huge app, right? Just build one page that does get one thing right. But if you are looking at like something really huge, something that's very complex, there's another much more mature and supported library called Web-Sharper, and there's some really interesting things been happening there too. You can also make one-page apps. So F-Sharp's quite rich here. There's not just one offering. And there's been a bunch of other F-Sharp to JavaScript converters. So using the same techniques, there's an F-Sharp to LLVM as well. Okay, yeah, so async. Show this async block before. This is, again, it's kind of a fairly trivial sample. Silverlight doesn't even have the ability to do modal dialogues, right? So this code here, this 5 or 6 lines of code, gives you modal dialogues in Silverlight. You show a window. You go over all the windows except the window you're showing, and you disable them. This is the fun part. We say the window closing event, right? Await that event, and we ignore the result. We're not interested. We just want to know it's closed. And when that's happened, go over all the other windows and enable. Well, that's the modal dialogue done, right? And we start that immediately, which means start on the UI thread. And that runs asynchronously. It's a beautiful model, right? C-Sharp's tried to, so this was in F-Sharp from about 2007. C-Sharp's recently got a version of this, a sort of a subset of this functionality. Some of the stuff's missing is like cancellation, which is kind of important in certain scenarios where you need to like cancel stuff. You can do it, but you have to do all the threading yourself. You have to thread things. So this is kind of just giving you a kind of feel for it. So in effect, for me, writing multi-threaded code is hard. It's like shooting yourself in the foot, you know. Writing synchronous code, we can pretty much reason about synchronous code. With the async model, you get to write your code like it's synchronous, and then you can say run it asynchronously. That's a big win. When I've been using F-Sharp, I do a lot of multi-threaded code. I haven't had any multi-threading issues, and the reason for that, I think, is I don't use the block keyword. Right, that's where things go wrong. I don't generally use mutable state. I do when I need to get really high performance, but generally it's to be avoided. And so F-Sharp's got a really sweet spot here for you. By default, everything's immutable, so you're safe. So the safety by default, everything's really readable. So again, I'm going to show you. Sorry.
I have a question. So what happens if window gets closed before the subscribe to close the event?
Oh no, it wants window. Oh.
It's a funny question.
No, it's a really valid question as well. So the question is, what happens if window close gets called before this happens? Actually, that shouldn't, in theory, happen because this will happen on the UI thread, right? And this workflow will also happen on the UI thread. So you can't re-enter the UI thread. So in practice, it can't happen because there's only one UI. But it's a good, it's one of those things that could happen. You could rearrange it, but it is stuff. Trust me. Instead of doing a mathematical model, I'm going to do some maths of a much prettier nature. We're going to do some fractals because that was my blog entry last weekend. And I love fractals. Great. So, just sort of seeing some async code in action. So I basically kind of done like a map zoom, a bit like Google Maps, but over the Mandelbrot set, which is kind of trippy and fun. And, Anyway, yeah, spent hours doing that. I'll try not to. We'll go and look at the code. So, actually, it's a bit of a mismatch. Some of the code for the box here, I just took from one of Thomas's async samples, and the other I stole from somewhere else. And but it was like putting it all together was the interesting thing, right? Oh, actually, I'll show you. Trying to talk about interesting things. Look in the top left-hand corner. There's a timing that shows for 2 seconds and then disappears. Right? It was quite subtle, wasn't it? I'm going to explain how I did that. It's quite cute. So, it's actually quite a hard problem to deal with, but the little timing thing, I create an async block, I sleep for 2 seconds, I've already added the text, right, with the timing on it. Sleep for 2 seconds. When the 2 seconds are up, I remove the text. Right? But I have to do it on the dispatcher thread up onto professions. The joys of Xamarin. I start a child task for that, so the whole app's still running, right? And that will just happen. Okay, so that's really cool. And I ignore the result because it just comes back to say I'm done. So that was really easy. Just really easy to reason about. It's as if I've written synchronous code. If we look at the code itself, this is a bit naughty, throwing itself live. Originally, I just had a single thread, but obviously, I want to be able to run as many. I want it to go fast because I want to zoom in and in. What I'm actually doing is every time you zoom in, I take the box that you've taken and I expand it up to the size of the screen so it feels like you get an instant result. And then I go in and I fill in the line. And I do a line for each processor and it sort of fills in like a fan, right? Because that's the most efficient thing for a CPU to do. And to do that, I just say, make a list of all the threads, of all the available processors in the system, and for each one, create a function to render. Just run those in parallel. And that does a fork join. So that will run them all. When they're all completed, it will come out. Right? So, no async reset manual event weirdness. Just do it. Yeah? You can do similar things with the TPL, but I can construct quite fun workflows with this. It's really powerful. It scales. There you go. The box itself, box drawing is somewhere. It's being implemented as a state machine. So you're either waiting for somebody to draw a box. When the mouse left button happens here, we're awaiting a mouse button in the waiting. Then we go into the drawing, which waits for the mouse button to go like up. And while it's doing that, it draws the nice little box and then it does this preview image. So that was pretty damn easy. And the nice thing is you're actually doing the state machine as functions. One function is waiting, the other is drawing. So you model the actual things happening. It's a far cry from imperative languages.
What's the M?
Yeah, so when you're doing a recursive function, you use AND to say it's recursive. So that they're mutually recursive, they can call onto each other. So by default, functions aren't mutually recursive in F#. In C# they are. And if you have a recursive function, you have to explicitly mark it as recursive with the rec keyword, which is another thing that say it's got your back. Basically, you can't accidentally do it. A number of times I've been doing C# and I accidentally wire a property to call itself, and bang. Okay, so yeah, async is great for fractals. Actually, I think Thomas has done a talk on this before, but we've just looked at really simple async, and it's kind of beyond the scope for me to go too deep. But once you've got this nice async capability, and then you've got something called an agent. And agents let you kind of build up these workflows and pass messages between the workflows in a safe way without locking. I really can't, it's like trading, I can't explain that in 2 minutes. But once you get into async, have a look at agents, have a look at one of Thomas's talks on that. It's awesome. You get kind of like Erlang style message passing built into the library, first class. And it feels very much like Erlang. I'm a big fan of Erlang, and the code's very similar. The default is like Erlang, it's in memory. You have to get a library if you want to call between machines. It's a lot easier to move between machines, at least in theory, with Erlang. Okay. So we looked at.
We should get wrapped up pretty soon.
I've nearly done that. Cool. Async we saw. There's embrace, which I think the guys came in. In theory, you just wrap your code with cloud instead of async, and it runs on Azure. That's pretty crazy, huh? And it does that by scheduling the code and dispatching it across the nodes that are available. This is pretty much the last slide. So on .NET 4 and before, you had fairly limited options for garbage collection, and so often people might just stay in C++ land if they're doing real-time trading system for fear of garbage collectors hitting in and adding latency. The great thing in .NET 4.5, there's a low latency mode, which I think they call financial mode. And basically, you can turn that on for your financial, sustained low latency for financial applications. You can give hints to the garbage collector to say, I'm doing something quite important now, leave me alone. Right? And more often than not, it will. These things are really important to us doing financial apps. It's a shame this only runs on above XP.
In finance, it's not about, in some situations, it's not about low latency. It's more often about fixed latency. It isn't very key, sort of latency.
Yeah, so this is just, that would be the sustained low latency. So it wouldn't be what you actually, the question is, you want fixed or a low latency rather than average low latency. Well, I guess that's, so what you want is you don't want this big spike that generates low latency. You want it to be fairly consistently slow, or but not slow. And so you would go for the sustained low latency for that one. So it's certainly more tunable. We've been able to get really good figures from really good results from the garbage collector, new 4.5 garbage collector. You could still do really well with the old one, but this is really getting closer to what you want. Okay. If you're interested in F-sharp, more interested in F-sharp, interested in for finance, go to try-f-sharp.org. There's a whole bunch of work through samples written by Thomas, actually, on trading and finance things with charts. So if you're new to trading, that might be interesting, or you just want to have a play with it in an F-sharp setting. Penultimate slide. This is an advert. Hoping you're interested in F-sharp. There's a great 2-day event coming up in September, the F-sharp tutorials, and it's focused on learning. So there'll be 2 tracks, one for beginners, and we'll get you right on the code from the start. Send along your teammates, get the whole team, get your friends knowing F-sharp so you can do more F-sharp. And there's also an advanced track for people who want to know how the compiler works and other crazy things. So Rick's running that conference. It's going to be awesome. We've got people from the Mono team coming down to enjoy it. It's an amazing lineup. We've got Don Sine, the creator of F-sharp, coming to give a keynote. And I think the prices are really reasonable as well. It's just about you coming down. I help organise the London events, but we literally take people with no F-sharp experience and have them to the point where they can work in a production environment within 2 days. Okay, questions?
Actually, 2 of them concerning your Joule app.
Yeah.
What is the UI written in? Is it like adult WPF WinForms?
So we had Silverlight, and we're now WPF.
Okay. Are you building your own controls, or are you using a third party and just customizing it as you need?
For performance reasons, mostly for the high performance controls, they're custom built, and the stuff that doesn't need to be high performance, we use like built-in controls. So the options menu, standard data grid, but like the grid that you saw with the prices on, that's custom all the way down. We found even like the third-party components were just not up to it for our trading app, which spans 9 screens and has to respond really quickly. It's kind of disappointing. You'd hope that the third parties could get their act together for finance, but they haven't. It's a good question. Actually, on that, the dual screen replaces existing C++ system. In a number of places, our code, our system runs 4 to 8 times faster than the C++ code while looking prettier and doing more things. So that's quite impressive, because that was not simple C++ code, that's highly optimized C++ code. Yeah, the C# and F# lets us sit above that and contemplate the algorithm. You have was that both questions?
Yes.
Other questions? Anybody noticed the awesome Manning cover?
Yeah.
Can we vote to keep that?
Yeah, what are they doing with those covers? It's crazy. Weird old people. This is how I'd have it. All right. Well, thanks very much. It's been kind of an epic.